for addresses and subnetting. And I just figured I'd make this video and go through this presentation to provide some overview for everyone. So again, if you've never seen another Network Academy online video, welcome. If you have seen it, and you like them, welcome back. Leave your comments, provide feedback to us, and we'll try to continue to improve the learning experience. Right. So let's start by talking about IP version 4 address structure. So what is an IP version 4 address? I like to describe an IP version 4 address as it's a 32-bit binary number that is written in dotted decimal. And an IP address has two portions. It has a network portion and a host portion. Now, I have provided an IP address here for you to see, which is 192.168.10.10. So this is the dotted decimal portion. But remember what the definition says here. It's an IP version 4 address. It's a 32-bit binary number that is written as a dotted decimal. So this is how it's represented for us to be able to consume it. But in essence, this is how the computer understands it. It's ones and zeros. We do not see it as ones and zeros, but that's how that is written as a dotted decimal. So this is how it's represented. We're going to look at what is a subnet mask. Consume it. But in essence, a subnet mask is also a 32-bit binary number that is written in dotted decimal format. And here's a typical subnet mask: 255, 255, 255, that 0. Now, IP version 4 subnet mask, what it does, it identifies what portion of the IP address belongs to the network and what portion belongs to the host. Remember on the previous slide, if I go back, I actually stated that an IP address has two portions. That is the portion that belongs to the network and the portion that belongs to the host. So now the subnet mask is going to help you identify which portion of that IP address actually belongs to the host and which portion actually belongs to the network. Okay, so if we look at the let's say, for lack of a better term, the typical IP addresses that are used, we're going to call them class A, class B, and class C, and those are the only ones we're going to deal with for this lesson. So the default subnet mask for class A IP is what we would call a /8, which is 255.0.0.0. And for class B, it's 255.255.0.0. And for class C, it's 255.255.255.0. We're going to be doing some binary math and show you how to break these down as we go through. So just hang tight and start, getting the concept. As we go through these slides, what I want you to do is to grab a pen or a pencil, take some notes, pause the video if you have to, go do some research in Google or YouTube, to fill in the blank. But grab the key terms, and you could also reference your text, like one book that I always recommend to my students, Introduction to Networks. It's a companion guide. All right. So now IP version 4 classes. We're going to talk about 3 classes. Again, class A, class B, and class C. Now, class A, it starts from 0 to 127, but 0 is not used, and 127 it's not used. 127 is totally reserved for loopback. If you ask me why they did that, I don't know, but it seems like a big waste, because 127, which is a class A IP address, could have actually accounted for 16,777,214 hosts that could actually be used on a on a network. Considering that we're running out of IP version 4 addresses, I think that was a big waste. But what is done already cannot be undone, right? Class B is 128 to 191, and Class C is 192 to 223. I'm going to provide some clarifications for this for you, because you might be saying, well, 128 or 191, what does that mean? 127 or 126, 125. What does that mean? A matter of fact, I could bring my whiteboard to the foreground so that you could see what I'm talking about. So let me do that. So when I say to you that a class A, I'm just going to write off to the side here, that a class A address is from 0 to 127, and we know 0 and 127 are not used, so just say 1 to 126. What I really mean is the first octet. So here we go. An IP address that goes like this: 14.127.5.7, say /24. This is a class A IP address. Why? Because the first octet, that is this number here, falls between 1 and 126. That's what makes it an class A IP address. And for class B, we tell you that it's 128 all the way up to 191. So an IP address that looks like so: 179.23.7.15, say /23, or whatever it is. It's going to be a class B IP address because the first octet falls between 128 and 191. Now, remember, I told you before, if you go back to the slides, an IP address is a 32-bit binary number written in dotted decimal. Each dotted decimal portion of the IP address is called an octet. So again, this 179, 23, 7, 15, this is one octet that gives you 8 bits. Another octet, 8 bits. Another octet, 8 bits. Another octet. So 4 8s, 32. That's why we say it's a 32-bit binary number. And this is what this chart here, is representing. All right. And if we go back to the slides for a minute, we will see here, if I just pull the slides up, if I may, we will see that a class C IP address falls from 192 to 223. So any IP address that actually have the first octet starting with 192 to 223 is going to be a class C IP address, right? So for this video, we're also going to look at converting dotted decimal to binary and converting binary to dotted decimal. And we're going to look at subnetting. So we're going to look at how we're going to create subnets. So take one class C network and break it down into smaller networks. Take one class A network and break it down into smaller network. Class B network, break it down into smaller networks, and so on. I'm going to show you how to identify the network ID. And I'll also show you how to identify the first usable IP, the last usable IP, and the broadcast. So hang tight. Lots of information to discuss. Lots of things to digest, but this is a recording, so you will totally be able to go back over it and just fill in the blanks. All right, so let me jump over here and grab my eraser for a little bit and just erase this board right here. Right, this is awesome stuff, guys. I could just go ahead and erase. So let's take our first IP here. The first IP, let me go back and select my pencil. First IP we're going to work with is, let's say I have an IP 179.23.15.12. Let's convert this IP into binary. So how do we do that? What we do is we look at each octet, and what we're going to do, we're going to plug the number on this table so that it totals 179. And you might be saying, well, Norman, what does that mean? Well, here's what I'm going to let you know. Well, if you add all these numbers up, that's 128 plus 64 plus 32 all the way down to 1, it's going to give you a total of 255. Now, a combination of these 8 numbers is always going to give you something between 0 to 255. I'm sorry, 1 to 255, right? So if we were to look at this, we're saying 179. Well, how does that work? All right, so we know that 128 is bigger than 179, right? So our 179 is bigger than 128. So here we would put a 1, right? And we would take, now, we'd say 179, take away 128, and that's going to leave you with what? 1, 5, right? Leaves you with 51. So 51's left. Can 64 go into 51? The answer is no, so you put a 0. Can 32 go into 51? The answer is yes. You put a 1. You go to 51 and you take away 32. When you do that, you're going to take 1 from here, so that leaves you with 4. Go here. That leaves you with 9. And this is going to be what? 19. So it's 19 are left over. Can 16 go into 19? The answer is yes. So you put 1 underneath the 16. You put the 16 here and you subtract it. It's going to leave you with 3. Can 8 go into 3? The answer is no. Can 4 go into 3? No. Can 2 go into 3? The answer is yes. And you leave 2, right? You're left with 1. Can 1 go into 1? The answer is yes. And there are no leftovers. So now this is 179. And we can look at it. 128, if you get your calculator and you do it, you'll see 128 plus 32 plus 16 plus 2 plus 1. You are adding all the numbers, the decimal numbers at the top where there is a 1. Where there's a 0, you're not doing anything to it. So if I may, I could go to my calculator. Let me find my calculator here. And I could say my calculator. And if you guys want to see me do it, I could say 128 plus 32 plus 16 plus 2 plus 1, and that gives me 179. All right, so that's how you do it. Very simple. Let's do 23. All right, so now when we look at this, we can see that this cannot go into 23. So we know it's a 0 there. 64 cannot go into 23. It's a 0. 32 cannot go into 23. It's a 0. Can 16 go into 23? The answer is yes. So we put 23 here, put a 1 there, and say 16. 16 into 23 is going to leave 7. Can 8 go into 7? It's a no. And this is 4 to 1, 7. So it's 1, 2, 3. And that will be equal to, my friends, 23. And the same thing we will do for 15. We can look at it and say 8 plus 4 are 12 plus, so that's 1, 2 plus 2, 14 plus 2, 1, 15, and that is 15. And we could look at this and say 8 here and 2, 8 and 4, 12. So everything else is a 0. So now that's how easy it is, my friends, to convert 179, 23, 15, 12 to binary. So let's put the binary equivalent up here. It's going to be 1, 0, 1, 1, 0, 0, 1, 1. That's 179. So that's your 179 dot 0, 0, 0, 1, 0, 1, 2, 3. That's your 23, right? And then we're going to say your 15 is 1, 2, 3, 4, 1, 2, 3, 4. That's your 15. And this one is your 12. That's going to be 1, 2, 3, 4, 1, 1, 0, 0, and that's your 12. So that's what it is, 179, 23, 15, 15, 12. All right, and it would be no different if you were to have that binary number. I'm going to write some binary numbers randomly and just convert it. So I'm going to leave this here so you could always refer to it on one page. So I'm going to say here, this is going to be 1, 2, 4, 8, 16, 32, 64, 128. We're going to draw the table. Sorry, the writing is not very Very good here. All right, so again, I really don't know what this is, but I'm going to write these numbers down here just randomly. I'm going to say 1 1 0 0 1 2 3 4 dot 0 0 1 1 1 1 1 0. So that's 1 2 3 4 5 6 7 8. I'm going to say 1 1 1 1 0 0 0 0 and 0 1 0 1 0 1 0 1. Right? Whatever that number is, we're going to convert it to decimal. So let's start. We're going to go on the chart. So we're always going to start from left to right. So it's 1 2 3 4 5 6 7 8. So this here, we're going to take this and we're going to say just add the numbers where we see the 1. This gives you a 192. We're going to say 1 2 3 4 5 6 7 8, and we're going to say this is 32 plus 16 gives you 48 plus 8. 48 plus 8 gives you 56. 56 plus 4 gives you 60. Plus 2 gives you a 62. Let's do that again, just so I'm not making a mistake. It's 32 plus 16, that's 48. 48 plus 8 gives you 56. 56 plus 4 gives you 60, and 2 is 62. And we're going to do the third octet, which is 1 2 3 4 5 6 7 8. So we know it's 128 plus 64, that's 192, plus 32 224, and 16 gives you 240. And the last one is 0 1 0 1 0 1 0 1. That's going to give us 64 plus 16, that's 80, plus 4 give us 84, and 1 equal 85. So this here, the decimal equivalent is 192.62.240.85. And that's how you convert from binary to decimal, and from decimal here to binary. That's how you do it, my friends. All right, so what are you going to do now? You know, I like to tell my students that perfect practice makes perfect. So you're going to use this as an example, and you're just going to change IP addresses out, and you're going to go ahead and just practice as much as you can. All right, so right there, I showed you how to identify IP addresses by classes. I also showed you how to convert dotted decimal to binary and binary to dotted decimal. I'm going to show you now how to actually find network ID, first usable, last usable, and broadcast within networks. So to do that, let me get a new whiteboard. All right, so I'll just pull that off to the side, and let's take a look at that. Okay, so now let's go back to my slide here and see exactly where we are. So we were given an IP address off. Let me get my pencil. And we were given an IP address off 192.168.20.0/24. And we were asked to subnet this. All right, so one of the things that we're going to do, I'm going to break this down into, I'm going to subnet this into a network that can actually take 14. Ooh, something happened there. let's get back to my pencil. I'm going to break this down into a network that can take into network of 16, right? 16. So if it's broken down to the network 16, therefore there are only 14 usable IPs. And here's how we're going to do it, right? So there is a formula, and the formula is that this 2 raised to the power of n minus 2 is equal to the number of usable IP on the network. And here's what I mean. What does this /24 means? This /24 is a prefix. It's just a form of writing the subnet mask. So there are 32 bits in a subnet mask, right? And we're saying out of that 32 bits, 24 are turned on. So if you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So remember the table that we used previously. If we put this on the table, which are 8 ones, and we turn them all on and add the decimal equivalent, what we're going to be getting is 255. All right. We looked at it. The table looks like this: 1, 2, 4, 8, 16, 32, 64, 128. And if we were to take this and put them there, 1, 2, 3, 4, 5, 6, 7, 8, and add them all up, we'd get 128 plus 64 is equal to 192. 192 plus 32 is equal to 224 plus 16 gives you 240. Plus 8 gives you 248. Plus 4 gives you 252. Plus 2 gives you 254. Plus 1 gives you 255. So if you look here, this is 255, 255, 255.0. That's your mask, your subnet mask. So all we're writing here is that 24 of the 32 bits are turned on. So therefore, the bits that are turned off, right, represents the host. The formula is 2 raised to the power of n minus 2 is equal to this. So in this case, is 2 raised to the power of 8 because there are 8 bits that are turned off minus 2, and that's going to be equal to 254. Because 2 raised to the power of 8 is 256 minus 2 is 254. That means on this network, by default, it could take, we have 254 usable IPs. The first IP in this block is 192.168.20.0, which is not usable as this is the network ID. We have 192.168.20.1 all the way up to 20.254, which are usable. And then we have 192.168.20.255, which is not usable. That's the broadcast address. That's your broadcast address. All right, so let me get back at this. So if I were to go over to here right now, and I were to say I want to break it up in /16, that means if I'm breaking up into /16, I need to, I need to turn off or turn on more bits, right? So all I need all the zeros that I need in the subnet mask to break it up to 16 would be 2 raised to the power of 4, right? And that would be 2 times 2 times 2 times 2, which in this case is going to be equal to 16. So if that were the case, the subnet mask would then look like 255, 255, 255, and you're going to take this here and say, I'm going to turn them on. 1, 2, 3, 4, right? And then the rest, which is 0, 0, 0, 0, are what's turned off. So now my subnet mask would look like so 240. So the subnet mask is 255, 255, 255, 240. And if it's 255, 255, 255, 40, what you're saying is then this is 8, 8, 8, 4. So that would be then a /28. So if we were to do that, this network, if I may pull this over, you always can go back to the recording, you know, and get what you want from there. So now, if I'm looking at this network, 192.168.20.0, 24, and we want to break it down to /28 subnets, right? Then we would be saying, hey, it's really /16. It's really /28, which is blocks of 16. So now we would be going from 192.168.20.0, which is the network ID for the first one. Then the first usable is 192.168.20.1, all the way up to 14. Then we have, so the first usable, by the way, that's not what we're going to calculate. The first usable now is 20.1, right? The last usable now becomes 192.168.20.14. 192.168.20.15 is broadcast, and 192.168.20.16 is the network ID for the new subnet. And then the first usable in this new subnet is 192.168.20.17. The last usable would be 192.168.20.30, and 192.168.20.31 would be broadcast. Now we have the new network, 192.168.20.32, which is the net ID. The first usable would be 192.168.20.33. And you got it, guys? We're counting, right? All we're doing is counting. And we're going to go all the way up to 46, which is the last usable. Then 192.168.20.47 would be broadcast. Right, and the new network would be 192.168.20.48. Right, so that's how you do to calculate the first usable, the last usable. But you're only going to get good at this if you practice. You have to do a lot of practice. So in this video, I showed you how to create the subnets, calculate the host in each subnet, identify the network ID, identify the first usable IP, identify the last usable IP, and the broadcast. And then after the broadcast comes the new network. Right? So again, if we just go back over the slides, I didn't have a summary, so I'm just going to go back and say, you know, we looked at the IPv4 address structure. We identify what the IP address is, right? You know, the different portions, which is the network portion, the host portion. We identify the subnet mask and talked about what the subnet masks are, you know, whether they and what it's used for. We also talked about the different classes of IP addresses, which is class A, class B, and class C. And we talked about converting IP addresses from decimal to binary, binary to decimal. And we also talked about subnetting IPv4 addresses, right? One thing I wanted to provide you here um, before we jump on to another video is to let me just get I want to move this over. So by default, we talked about the different classes of IP address. So we have class A. The default subnet mask for class A, by the way, is a /8, which means that only 8 bits are turned on of the 32. So that gives you 255.0.0.0. And class B subnet mask is a /16, which means 255.255.0.0. And class C is the default is /24, and that means 255.255.255.0, right? So, I hope this provides you with some clarity as it pertains to IP addresses. And I hope that, you'll be able to use this to enhance your skills as we progress through this, this learning process. All right. I want to thank you very much for watching, and I see you again soon in another Network Academy Online video. Thank you very much, and I will see you soon.